You must have heard of the elimination method of solving simultaneous equations. There are basic three methods of solving simultaneous equations. We have the elimination method, the substitution method, we have the graphical method. We could also use the matrix method of solving simultaneous equation. But in this class, I'm going to teach you how to use the elimination method. The elimination method basically focuses on eliminating one of the variables. Eliminating one of the variables. There are two variables in this equation. We have A and we have B. And so the elimination method means that you eliminate one of the variable and solve for the other variable. Just imagine you eliminate A and then you have your equation in terms of B. Then you'll be able to solve for B. So, to use the elimination method, there are a few steps you need to take note of. One, ensure that the coefficients of the variables are the same, the variables you want to eliminate. In this case, you are free to eliminate any of the variables. You can either eliminate A or you eliminate B. But the rule remains the same. To be able to eliminate, ensure that the coefficients are the same. So the coefficient of A here, first of all, let's call this equation 1 for the purpose of description. Let's call this equation 2 to be able to describe. So the coefficient of A here is 4. The coefficient of A in equation 2 is 2. The coefficients are not the same. The coefficient of B in equation 1 is plus 12. The coefficient of B in equation 2 is plus 3. The coefficients are not the same. And so in a situation like this, we need to adjust the equation such that the coefficients are the same based on the letters you want to eliminate. So, to be able to do this, first of all, it is important we identify the LCM of the smallest coefficient. Okay, this is what I mean. The coefficient of A here is 4, the coefficient of A here is 2. So let's look out for the LCM. The LCM of 4 and 2, I suppose that's going to give you 4. Okay, look out for the LCM of B here, the LCM of 12 and 3, that's going to give you 12. That is the LCM, the lowest common multiple. It is good to eliminate the letter with the smallest LCM. That is, it helps you to avoid bigger numbers. Again, the essence of you finding the LCM is, number one, it helps you to avoid bigger values. And so, again, we said the LCM of A in both equations is 4. The LCM of B in both equations is 12. So it is better we make A the comfortable for elimination because it has a smaller LCM. So therefore, what then do we do to make the LCM the same? So this is already 4. The coefficient of A here is 2. So what are we going to do to make this 4? What are we going to multiply by 2 to give us 4? And that's going to be 2. So what we're going to do is to multiply the entire equation 2 by 2. Is that clear to you? Multiply the entire equation 2 by 2 so that you are able to achieve a coefficient of 4 here. So we say multiply equation 2 by 2. And for equation 1, we say we are multiplying equation 1 by 1 because we want to retain the same expression there, and equation 1 by 1. By 1 because 1 is a neutral element when it comes to multiplication. Whenever you multiply by 1, we give you that thing back. So multiplying equation 1 by 1 will not change anything there. So 1 times 4a, you see as is 4a. 1 times plus 12b, that's plus 12b. 1 times 16, that is 16. And so we still call this equation 1 because nothing has changed. So remember, we say multiply equation 2 by 2. So 2 times 2a, that's 4a. 2 times plus 3b, that's plus 6b, equals to 2 times 7, that's 14. So we call this equation 3. Equation 2 is now 3 because we've adjusted equation 2 by multiplying it by 2. So now when you look closely, you see that the coefficient of a in equation 1 is 4, the coefficient of a in equation 3 is 4. The coefficients are the same. So what do you then do to eliminate a? Let's consider the sign. Whenever the sign of the variable you want to eliminate are the same, you subtract one equation from the other. Whenever the sign are the same, so here this is a plus 4a, this is plus 4a. It would have also been minus 4a and minus 4a. When the signs are the same, you subtract one equation from the other. But when the signs of what you want to eliminate are different, you add up the two equations together. When the signs are different, you add up the two equations together. So in this case, the signs are the same, so we subtract one equation from the other. And it does not matter which equation you subtract from the other. You can either say equation 1 minus 3, or you say equation 3 minus 1. All you need to do is just to stick to the rule that ensure that you are subtracting like terms. So I want to go with equation 1 minus equation 3. So yeah, 4a minus 4a, that's 0, plus 12b minus 6b, that's 6b, equals to 16 minus 4, 2, and the value of b, the coefficient of b is 6, so b equals to 2 over 6, and needs to give us 1 over 3. So now we have the value of b, we need to get the value of a. To get the value of a, I would prefer to substitute b in equation 1. But of course, you are free to substitute b in any of the equations you have, whether equation 1, or equation 2, or equation 3. So I want to go with equation 1, so I say substitute b in equation 1. So whenever I see b, I'm just going to write 1 over 3. So equation 1 here, I have that to be 4a plus 12b, so I write this as 1 over 3, equals to 16, equals to 16. So I have 4a plus 12 times 1 over 3, 3 here 1, 3 here 4, so 4 times 1 is 4, equals to 16. So 4a equals to 16 minus 4 when you collect your like terms. And so this is going to be 4a equals to 16 minus 4. That gives us a value of 12. And a will be equals to 12 divided by 4. The value of a is 3. So we get a to be equals to 3 and b to be equals to 1 over 3. So that's the value of a and b. Please click on the subscribe button, share, and leave your comments. I'm going to see you in the next teaching. Bye-bye.